All right, question 4. So they tell us f of x is x plus 8 over 3, and they want to know f inverse of 6. Okay, that's how you read this. This means inverse. So what is f inverse of 6? Well, one way that you could answer this is by actually finding the inverse function, which is going to be 3x minus 8, and then you could just plug in 6 for x, all right? So what does that come out to? 10, right? The other way to think about this question, which I think is simpler in many cases, is you're not plugging in 6 for the original function. No, no, no. What you want is you want 6 back as an answer. Okay? So you would think about, hey, what do I need to plug in for x so that I get 6 back as an answer? So you could say 6 is equal to x plus 8 over 3 and just figure out what x would have to be. All right, and that's why 10 is the solution. You multiply by 3, so that gives you 18, and then subtract 8 from both sides. Gives you 10. Okay, number 5. These two functions are inverses of each other. Yay. What is f composed with g of x? Okay, now since we know that these two functions are inverses of each other, we automatically know the answer is going to be x. All right, it's just the number that you start with there. That's what it means for two functions to be inverses. They undo each other. But if we were to work this out, it would be f of g of x. That's what they want us to do, which is f of 1/4 x minus 2. So what I would do to evaluate this is I would replace my original x with 1/4 x minus 2. So it would be 4 1/4 x minus 2 plus 8. And then by the time you work this out, let's see here, that's going to become 1x. That's going to be negative 8. You're left with a giant x. There you go. But honestly, the easy way is just remember that when you compose two inverses, they cancel each other out. All right, that's what it means to be inverses. Okay, which of the following shows a graph with a function and its inverse? So the trick here is that the two functions, they have to be a reflection of each other across the line y equals x. That was one of the properties about inverse functions. So y equals x is the little line that goes straight up the middle at a 45-degree angle. Those two are not a reflection across that line. Those two are not either. I think I found it. Yep. These two. These are a reflection of each other across that y equals x line. The other way to tell is they gave you 16, 0 down here. Or sorry, negative 16, 0. And so on the inverse function, or the other one, that ordered pair is just flipped. Okay. 0, negative 16. That's what should happen. The x and y should all just be flipped from each other. All right, question 7. Determine if the inverse is going to be a function. So this one is a no, and that's because it fails the horizontal line test. All right. If you fail the horizontal line test, then the inverse fails the vertical line test, which means it's not a function. All right, this one would be a yes because it passes the horizontal line test. This would be a yes because it passes the horizontal line test. It only crosses once everywhere you draw a horizontal line. This would be a no because right here it fails the horizontal line test. And then the last two are tables. Okay, this would be a yes. The inverse would be a function because none of the y values, these f of x values, none of them are repeated. So if you were to switch the order replacing this column with this column, every input would match to one output. So this is the inverse would be a function. This one would be a no, because the 5 is repeated on the output side. So the inverse would not be a function.